Please how to say your name so I don't.
It's a champon.
Oh, okay then. I saw AKAMP.
Yeah.
Oh, is that how you spell your champon, right?
No, it's AKY.
Okay, then the Y was missing. Sorry. All right. Yeah, pardon me. All right, let's have more
It's okay. Okay. May we all get into the mood of prayer. Father Lord, we thank you once again for bringing us together to witness this great opportunity to share knowledge and skills to equip all of us to improve upon our knowledge. We pray that this program goes successfully, and then at the end of it all, we'll say glory and honor and adoration to your name. In Jesus' name, we've prayed with thanksgiving and for an answered prayer. Amen.
Amen. Wonderful. Yes. All right. Miss Adubankas, I hope this one I'm not wrong. Please kindly give us our opening address.
Thank you very much, Honorable Ben. And it's my pleasure to come before you all to welcome you to this seminar. And then the aim of this seminar is to bring our students together to learn and then develop our skills in research. And I'm very much grateful that we have ourselves gathered here to gain some knowledge. We hope that this program will be impactful and then it will be beneficial to all of us. So thank you so much for joining. And then I hope you have a wonderful time learning. Thank you.
All right, thank you. That was swift and brief as it should be. I do believe those that have joined us from day one, starting from Friday through to yesterday and today, that are joining us today, you've been so much impacted with a series of insightful messages and presentations. Today we are going to take our last two, I would say, and it might not be the last, it might be the beginning of something great in your academic journey. Today we are actually going to look at top tips for high impact academic writing. Like I said, we've had some presentation about how to build good relationship with our supervisors and all our conduct in our research work. Today we are going to look at the first presentation. We are going to look at publishing or getting published in high impact journals. When you always see top tips, I think even we have this clickbait in all that, in those that are into digital marketing and publishing and all that, you get to know that people, when they want you to get hooked to certain things, they put top tips. These are not, hookup lines. These are genuine. So if you are here, just pick your pen, pick your notes as we get into some insightful lecture from Professor Mauli Jakpasu. I hope I've mentioned this right. Professor, please, if I haven't, Prof, please pardon me. Now, let me tell you a little bit about Prof, so that you put yourself at ease while you get your notes ready. So Prof is currently an associate professor of the School of Environmental and Municipal Engineering in Xi'an University of Architecture. So Prof. Jakpasu obtained both his bachelor degree and master's degree from the Kwame Nkrumah University of Science and Technology, just right behind my my catchment area. Yeah, that's to say that I'm also from Kumasi, Prof, and I live right behind your your former school or your alma mater's wall. All right, so he later moved on to Ireland, where he obtained his PhD from the Dundalk Institute of Technology. Well, his professional life didn't begin until he went into the University College in Dublin, where he served as a postdoctoral research fellow. He's currently an associate editor of Ethiopian Journal at the IWA Publishing. And we have this figure, we have this personality in our midst today. So it's not your ordinary research show or research workshop. It is going to be very much impactful. I wouldn't want to waste time. Let me invite Prof. Prof, with your honor and your permission, your people are ready. Please, the podium is yours.
Okay, thank you very much. Just give me a minute here to share my screen.
Okay. Yes, it's visible now, Prof. Yes.
Okay. Okay, thank you very much, and a very warm welcome to everyone. Before I begin, I give you a brief overview of what to expect in this lecture. Let's have a little chat about the mere importance of this topic. So this idea of high impact academic writing, why is it important? Well, many students, as I've come to realize, struggle with writing. Firstly, because they don't realize how much writing they have to do, but also they underestimate how important it is to write with meaning and with clarity. Okay, so we definitely need as much support as possible to help us to write well, especially as postgraduate students. So in this webinar, I would like to present a range of principles and practices that can help us to write better as postgraduate students. So I want us to look at first the relationship between thinking and writing, and when to start writing, the golden thread, as well as some useful principles that we can use to help us write to please our readers. I will also provide you with an improved understanding of the structure and underlying logic of research articles, particularly for those published in international literature, and also give an overview of the strategy for turning a set of results into a paper for publication. We will do this by analyzing the structure and language features of some scientific articles so we can use the results of this analysis to improve our own scientific writing. So some of the practices that we'll talk about will help you with better sentence construction. And these include old before new information, concrete subjects, complexity last, and many ways to ensure that your writing deals directly with what you are trying to convey. In the first topic, we will look at the relationship between writing and thinking. It has been said that learning to write is learning to think. You don't know anything clearly unless you can state it in writing. Now, this is even more true for you as a postgraduate, when your writing will often be the only evidence of your thinking. So it is crucial that you focus on writing with clarity and with meaning, because this will ensure that your thought process are just as good. Okay, so now many students make the mistake of spending too much time thinking, assuming that when they come to write something down, they will have a perfect recall. But this is a fallacy and could lead to a lot of your inspiration and academic progress never actually contributing to your research field or even to your success as a student. So once you write something down, you have a better sense of how to express your thoughts, and this in turn improves your next thought process. Therefore, I always acknowledge practicing generative writing, which is your own note-taking, much like a researcher's journal. So this will test your thinking in bite-sized chunks as you go, rather than waiting until you have a report to hand in. And this also helps you avoid a backlog of unexpressed or unwritten thinking. Okay, so if you don't commit your thinking into writing, then your mind has to keep it somewhere. And this limits the space and capacity you have for doing new thinking. Especially for those of you doing a multi-year study, you will really struggle if you rely too much on your memory when the time comes to complete a writing project. So some of the ways that we can integrate writing and thinking, we are going to look at include free writing, mind mapping, brainstorming, and journaling or memoing. Okay, sorry about that. So the first we'll talk about is brainstorming, and I suppose most of you are familiar with that. And this approach requires more than one listener to be in the room. It may just be you and your supervisor, but it can also be your study group or your research buddies. And it is always good to have a research buddy because they can support you or you can support each other. And sometimes when you get, you reach a block, then your research buddy can help you. The next technique has to do with mind mapping. So mind mapping is a visual representation of what you are thinking and also how you are thinking, okay? So the mind maps are spatial and not linear, and you are using it to capture your ideas and then categorizing them at the same time, okay? So you can use mind maps to take notes in class, but most especially to plan your research and to represent your literature review. So here we have an incredible free mind mapping website with very many resources and techniques. It's called the IQ Metrics, and it gives a pretty complete guide on how to mind map for beginners. There are lots of resources here offering several free videos and tools on how to mind map, etc. So I strongly recommend that you have a look at this website. But here I want to show an example of a mind map that was developed by someone for his thesis review, okay? And he actually incorporated this mind map into the actual dissertation when he presented it. This made people liked it because it does give a one-page view on what the literature review looks like, okay? So in here you see many branches, and the main branches here represent the main topics that are being discussed in the literature review, with each sub-branch representing other subtopics. Now, there are many free softwares available for mind mapping. Of course, you can do it manually by using flip charts and whiteboards, etc. The other type of writing is free writing, okay? So here, one of the really good authors on free writing is called Badenhorst. He had a quote, a direct quote, which says that the free writing techniques involves timed writing sessions where the writer writes expressively without correcting, okay? And they are encouraged to separate composition from editing to keep their internal critical voice quiet during the composition. So in essence, you decide how long you are going to write for, and then you just write, okay? And the last technique here is journaling or memoing. And this is where you write reflective and analytical notes to yourself, okay, particularly about the research process, your lab experience, difficulties with accessing data insights, patterns about your figures, and anything that comes to mind. Okay, so this is analytical. So you are thinking and you are writing, but it's also yourself. Okay, nobody else is going to see it or judge it. Okay, so it's important to get into the mode of writing these memos and journal entries because they often make up a great deal of your final text. Okay. Remember, I said, do not rely on your memories when it comes to writing. So if there are any theoretical concepts that can come to your mind as you write, you need to capture those as well. And you may even think of relevant articles that pop into your mind as you're journaling. Okay, so this can serve as your references also. Okay, so now I want to look at some of the critical elements of a scientific paper.
Yeah, hello, Prof.
Hello?
Sorry to interrupt. Please,
Yep.
would it be convenient for you to show your video? I think,
A video?
I don't know. I mean, turn on your video or, yes.
Let me see.
Yes, please, yes. Yes,
Is that all right?
Yes, please, it is. Thank you so much.
Okay.
I'm sorry for the interruption.
All right.
Yeah.
Okay, so we go on. So a paper essentially is a representation of your research data, okay? The data that you have produced in the lab in a definitive and in a conclusive form, okay? Or in other words, sorry, I see something wrong. Okay, so in other words, you are trying to present the data that you've gathered in a concise and in a convincing form. Unfortunately, they say that your blood and your sweat don't count. Okay, so how you suffered to gain your data, nobody cares. What people care about is novelty and scientific proof. Okay, are you bringing anything new to the literature? And are you able to give good evidence for this new information? And for those of you who will end up in academia, then your papers are also your professional portfolio, okay? So it is worth to do them well. Now, I often like to compare the making of an article to an athlete or a sports person preparing for a race or a competition. Usually, these people will train several times before the actual competition starts. So it is the same when you are trying to write a paper. You don't begin today and say, I want to write a paper. You have to start thinking your paper long before you start, okay? So that will give you ample time to look at what data is good enough to be put into your article. Okay, so in working towards your paper, there are 3 important points that you need to consider. That is how your data is generated, how the data is made into a story, and how the data is presented. Okay, so when it comes to data generation, you have to realize that in today's science, it is all about teamwork, okay? So this has some ramification. That means that you help others and others also help you, okay? So talk to your colleagues, okay? Share your data so that they can help you to get more insights into whatever data that you have. When we are generating the data, we have to make sure that the quality is good and that it can be presented for publication, okay? Now, there are several work areas that might influence the quality of the data that you generate, okay? So if you were to improve the quality of the data, where would you have to start? Obviously, you will look at where we have the highest impacts, okay? So the other areas that have lower impacts are areas that usually we cannot control. So for example, you had to go out for a break, or there was traffic, so you were not able to get to the lab early enough to get your data. Those ones you cannot really control. The ones that you can control, it's your mindset, okay? So this comes to people always thinking that I have to do it again anyway. So they don't take proper care in making the data good enough, okay? So try to make every single experiment publication quality. In this way, you can have good data. And the second is failure to document your experiment properly, okay? So unless you make a figure out of the data that you have generated, this is an experiment that nobody will know about. And so it is like never done, okay? So every experiment, try to make data out of it or a figure out of it. So the remedy here is simple. Try to make every single experiment publication quality, okay? Make the figures of your experiment as you go. Don't wait till the end of all your experiments and then you are struggling to put your figures together. Once the experiment is finished, you put it into a figure and store it, okay? So I would like to say a few words about experiments, because the experiments are the foundations of our papers, and most particularly, they are the foundation of modern science, okay? So science is founded on the principle of observation, causality, and reproducibility, okay? But then there is a problem. Because you cannot verify every observation, okay? You can only falsify it, okay? So for instance, in this example, the observation we say, I give an example as sometimes seeing smoke, okay? So that is the observation, and the causality is that wherever there's fire, there is smoke, okay? Reproducibility here is that fire will always cause a smoke, okay? But there can be instances where you have smoke coming from dry ice, okay? So this observation here cannot be verified, okay? It can only be falsified. Okay. So when you are having your experiments, remember your experiment should always address a relevant problem. It has to be controlled, okay? And it must be reproducible, okay? Somebody should be able to do the same experiment and get similar response or similar results. And then it must be falsifiable, okay? The upshot here is that the experiments have to ask a question that is relevant and a question that can be falsified, Okay, so this forms your hypothesis. The question that can be falsified will form your hypothesis. So the questions that are relevant are questions that pertain to an interesting correlation or an unseen observation, okay, where the answer can be used to explain something, okay? So the questions that can be falsified are questions that are simple. Usually I recommend one line at most, and they can be answered simply with a yes or a no, okay? And we have here that causality is impossible to establish formally. The best approximation is a consistent relationship, or a consistent correlation, so that the falsification has failed repeatedly. So in formulating your hypothesis or your question, first, you need to have one question per experiment, okay? The question has to be simple. I recommend one-line questions, and it has to be answerable, okay? And the answer will have to explain something, some phenomenon, okay? If it does not explain a phenomenon, then it has to decrease the number of possible explanations, okay? And as I said, the answer must be yes or no. Avoid all cases of a maybe type of answer. So in planning your research, your experiment, it is important to plan, okay, to go through the experiment step by step on paper, and make sure that all that you need are available before you start, okay? And only do as many samples that you can handle, making sure that samples that need to be compared directly are included, okay? So this includes your controls. The negative control is absolutely essential. Any experiment without a control is useless. And if you can do more than one negative control, you do it. Positive controls whenever possible. And also, if you can do more than one, do it, okay? So why do we need controls? We have to understand that experiments are almost always comparisons, okay? You are comparing something to another, okay? Or comparison between two or more states or anything, okay? So assuming that you are conducting an experiment, the negative control here will be the worst results that you can get, okay? And the positive control will be the best result that you can get, so that the sample that you are testing will fall somewhere in between. And you can use this comparison to write about your results, okay? So somebody will ask, what is a negative control? Usually a sample that will contain everything except the one component that you are analyzing or you are assaying, that will be the negative control, okay? So this will be the point of control, be the point of reference against which you measure changes in your sample, all right? The positive control then is a sample that is proven to change during the conditions of the experiment, okay? So the positive control will tell you that the experiment has technically worked, and it provides a reference for the type and extent of the change. So here we have some examples. So for the positive control, if you want to, for example, assess a new test's ability to detect a disease or a contaminant or anything, then we can compare that new method to a different test that we already know to be able to detect that particular disease or that particular parameter. Okay, so the well-known test becomes your positive control because we already know that the answer to the question is yes, it can detect this particular parameter. Okay. So we have another example here. In an enzyme assay to measure the amount of an enzyme in a set of extracts, a positive control will be an assay that contains a known quantity of the purified enzyme, okay? On the other hand, the negative control will contain no enzymes, okay? So the positive control should give a large amount of enzyme activity, whereas the negative control, because it has no enzyme activity, should show, you have no enzymes, should show very low activity, okay? Now, if you have a positive control that does not produce the results that you expect, there may be something wrong with the experiment, okay? And that means that your experiment has to be repeated. Okay, so that is also a way to measure the experiment that you are conducting. The negative controls are groups where no phenomenon is expected, as we've seen in that example. So they will ensure that there is effect when there should be no effect, okay? They will ensure that there is no effect when there should be no effect, okay? So for example, in testing, a negative control is a group that has not been administered with the drug of interest. So for example, you have developed a drug and you want to know whether that drug actually works in humans, okay? So the control group, the negative control group, will be the group that does not receive this particular new drug that you have developed, okay? Okay, so I'll skip this slide. So just some do's and don'ts for experiments. Okay, what is important to do here? I said, try to make every experiment publication quality, okay? And try to document your experiment properly. That means trying to make a figure out of the experimental data as soon as the research or the experiment is done, okay? And then keep in mind that unexpected results are often due to technical failure, but if they are not, they will lead you to new findings, okay? And some don'ts. Don't be biased when you are asking your questions, okay? The point here is not for you to like the answer that that you get, but trying to get an answer that explains some phenomena that you want to understand, okay? And do not believe in one-off experiment. Okay, remember we said that science has to be reproducible. So that means that you need to be able to replicate the results that you get from a particular experiment. Okay. Okay, so we assume now that you know how to collect your data, and so you are ready to write. Okay. Of course, it's a bit of an art, but it can also be learned. Now, in writing any paper, you must make conscious effort to tell a story from your data, okay? Only in few cases, the data themselves speak for themselves or tell any story. So that means that you have to lead your reader through the story that you are trying to tell, okay? So it's almost like writing a screenplay for a movie. So let's start talking about a famous movie. Here I have the Titanic, and the story is about a lady called Rose that was traveling in a ship with her fiancé called Carl, okay? And she meets this wonderful gentleman called Jack, and she fell in love with him, and the story goes on, okay? But it is also about a ship that was built in Belfast, moved to Liverpool, and started a journey through Cork and travels through the Atlantic, eventually hitting an iceberg and sinking, okay? So that's the story of Titanic. When you write the screenplay for such a movie that only talks about the ship, its travel, and hitting the iceberg, that will look like a documentary and not that kind of high impact or big impact movie that you are looking for, okay? So to make it into a movie, you need to include additional sub-stories, okay? So for example, we also had the captain, John Smith, who was also planning his final voyage before he retires. And we had the fiancée and her mother, Ruth, okay? And we also had Bruce, a rich, ignorant, upperclassman, okay? And there were many other characters and many events in this movie. So the point I'm trying to make here is that different people connect their lives with different parts or different events in the movie. So a piece of academic writing is exactly like this. Different people will look for different information from your paper. So just as a movie, there should be logical progression in academic publication. So this is an example of one of the papers published in my group recently. And it had a main story, okay? So the main story was on the system performance, but we also had some sub-stories. So for example, we had phytoaccumulation, we had the microorganisms, we had toxicity and detoxification responses, okay? So these were all sub-stories, but we also had other stories, okay? Ecological impacts, metabolites, etc. So writing a paper is like writing a screenplay or directing a movie, because you have to focus on a story. There should be logical progression, and you need to keep a suspense, okay? So you need to keep a lot of sub-stories. You have to have a good conclusion, and at the end, there should be a take-home message, all right? So before you begin to write, you have a rule of thumb. That is, you should not consider publishing if the work is outdated, okay? remember we said novelty counts. And you shouldn't consider publishing if you will be duplicating previously published work, or if the conclusions are incorrect or not acceptable. Okay? So these points are good indicators that your writing lacks scientific interest or does not substantially advance the field. Okay? So you should consider publishing your work if you have information that advances the field or the research field. And that could be in the form of presenting new ideas, okay, or original results, or some new methods. Or it could be rationalizing, refining, or interpreting some published results. And in terms of review articles, it must be reviewing or summarizing a particular subject area or field. Remember that a strong manuscript and a message is crucial in order to present your contribution to the scientific community. Okay, so what will make a strong manuscript? A strong manuscript will have some key characteristics. Here we have 3. The first is that the scientific message is clear, it is useful, and it is exciting. Okay. The second is that the message is presented and constructed in a logical manner. Okay. Remember the screenplay? They will enable the reader to arrive at the same conclusion as the author, and the format chosen is best for showcasing the material that you have. All right. And the third is that they enable the readers and also particularly your reviewers and the editors to easily grasp the significance of the research that you have done. Okay. So remember that editors and reviewers and also readers all want to receive well-presented manuscripts that fit within the aims and the scope of any journal. Okay, so that should be the first thing you look at. Now, there are many types of manuscripts that suit different purposes. So we have full articles, and these are the most frequent type. Okay, and they are supposed to present substantial, complete, and comprehensive pieces of information that are of significance. But we also have letters or short communications, and these are quick and early communications of significant original advances. Okay, so you have some results that you think is very exciting, very new, that people will want to know very quickly. Then instead of publishing a full research article, you rather submit it as a short communication. Okay, and then we have review articles which summarize the current developments. Okay. Now, it is very important that you select an appropriate journal so that your work will reach the intended audience. Okay, so if your paper is outside of the scope of any journal that you choose, then it is likely going to be rejected immediately by the editor. Okay, not even because of the quality of the work, but because the topic doesn't fit the journal. Okay, so it is very, very important that you do not gamble by submitting your manuscript to several journals at one time. Okay. Remember that your supervisor, who is often your co-author, has the responsibility for your work. So you have to ask them for help. Okay. Now, in investigating all candidate journals to find out their aims, the scope, the types of articles that they accept, their readership, and the hot topics that are currently prevailing is the first and most important step, okay? So here we have an important tip is that articles in your reference list will usually lead you directly to the right journal, okay? But even in that case, you still have to look at all these factors. One other consideration for selecting a journal is the impact factor, okay? So the impact factor will tell you how many times recent papers in that journal are cited on average in any given year, okay? And it does not give an indication about citation of individual papers, but the papers that are published within that journal itself. So how do you relate your work to the impact factor? Okay, first, we have already mentioned novelty, okay, but also revelation, relevance, and impact of your paper are important, okay? So in terms of novelty, if the work is so new that nobody has seen it before, then you can aim for a very high impact journal. On the other hand, if you are only using your data to confirm some other previous findings, then you have to aim lower in the impact factor ranking, okay? In the same vein, the mechanisms and the extent to which your paper or your data reveals the mechanisms can influence what level of impact factor you can take or you can submit to, okay? So that if the mechanisms are being revealed, then you can aim for a very high impact factor range. On the other hand, if it's just an unexplained observation, you observe something, but you cannot explain the mechanism, then you cannot target a high impact factor. Okay. In terms of relevance, okay, you are looking at how the mechanism or the phenomenon that you have studied really relates to practical applications, okay? So if
Doctor, please,
you are trying, you are
muted.
able to.
Prof, I
Yes?
think check your mic again.
Is it off?
Okay, yeah, I think it's better. Sorry. Yeah, it's better.
It's okay. Where did you lose me? Should I go back or?
Yeah, no, I think you can continue. So just
I can continue. Okay.
Yes, please. Sorry.
All right. Okay. So in terms of relevance, if you are able to provide proof of some physiological relevance, then you can aim on the you can aim at high impact journals. On the other hand, if it's just a purely in vitro study, then you can look at low impact journals. And then lastly, we have the impact of your work. Sorry. The impact of your work, okay? So the results that you make, should make a difference, particularly for further research, okay? So that if you are providing definite solutions or giving completely new direction of research, then here you can also aim at high impact journals. And then on the other hand, confirmation of any existing hypothesis, you only aim at a lower impact factor, okay? So I hope this can help you in the future when you are selecting your journals. Now, next, I would like to look at the process of building an article, Okay, so the sequence of writing the article is usually not the same as when we read it. So for most scientific fields, the most efficient way is to regard the manuscript as a wall built with bricks, okay? So you are building the article brick by brick, all right? So you start with producing your tables and your figures, okay? So that's why I said you make your figures as you go, you finish your experiment, you make a figure out of it, okay? So you begin building your wall or your article by gathering all the figures and tables that you got from your experiments. Then you can describe the methods, how you were able to get these figures, the results, and the discussion around them can also be written, okay? Then the conclusions should flow on from this fairly easily. And finally, you can write the introduction as to where your work fits in the whole field of study, okay? Finally, you can write the title, the abstract, and the keywords. So this process of building the article is easier, it's more logical, and more effective than trying to write the article in the sequence that it is read. So just as a guide on how to start, okay, so first gather all the experiments that you have done. Remember, experiment is equal to figure, all right? Otherwise, nobody knows about it. Then you are going to sort out the useful ones. Remember, not all your experiments will provide useful results, okay? So select those that are technically sound, and most importantly, those that are reproducible, okay? Then you can attach post-it stickers to each one, describing the title and what question it is answering. Or in other words, a conclusion of that experiment, okay? So now you're going to spread out all the figures and then look at it and group them into common themes, okay? After that, you can sit back and look at how you'll be able to form a story out of that. So this is how they used to do it in the movies, okay? This is called storyboarding. And here we have a storyboard for the first Star Wars movie, as I remember it growing up. And they have all these scenes, but they are not sure of what order or the best sequence of these stories. So what they do is to draw them up in the form of cartoons, okay? And then they move these cartoons around, okay? Until they can tell the story as they like it, okay? So we tend to do the same with the figures and the tables for the articles that you are going to write. We will move them around until they tell a story that is clear, okay? And then to develop a narrative, we can use the sticky notes to develop a summary. That is, for each figure, what is the main conclusion, okay? What is the main finding? Then we can move them around until we feel comfortable. Of course, you can use all the tools that I have discussed in the beginning of the lecture, okay? So the mind maps and the all the others, they can help you at this stage, okay? How are we doing on time? Do we have enough time? You let me know if time is over, okay? Can anyone hear me?
Yes.
Okay, all right.
Yes, please, we can hear you.
Okay, thanks. Okay, so here I have some thoughts about how to select your data, okay? Remember that selecting your figures means that you are inevitably selecting the data, okay? So just as I said before, make sure that the figures are accurate and they represent the real data. If they don't, then beware that you are committing fraud, okay? So for instance, if you did 5 experiments and all of them show the same outcome, then it is fine to splice them together to make the figure look better. But if you did 5 experiments and 4 is showing one result and the other one is showing something else, then of course, there should be no question which one to select, okay? You have to strike out the one that is taking something different. So if you have divergent data and cannot be sure what is right, then that means that you have to do more experiments or you have to repeat them and make sure that you can falsify them or you can confirm the data that you have. In terms of telling the story, remember always to tell a good story, okay? So a good story has to make sense, all right? A good story should have a main question or a hypothesis, and it should have a conclusion, okay? And remember, do not dilute the story by presenting too many angles. Even though we are talking about presenting sub-stories for each paper, there should be a limit as to what will dilute the main story beyond recognition, okay? So take that in mind. And a good story has to convince. You should be able to convince the readers of what you are trying to tell them, okay? That means that you have to support your case, for example, with different experimental approaches that will arrive at the same results, okay? So that if you have multiple methods that is giving the same results, then of course, it means that you have a very strong result, okay? And here I have put that you can use a courtroom thriller type of approach, okay? So as an example, we have here the evidence you have seen in figure 1 suggests that the candidates under investigation have been at the crime scene, okay? Therefore, we directly examine this possibility, okay? So use that kind of courtroom kind of drama to give the support. So we have seen that making figures is very important for your scientific articles. So how do you make figures that can be convincing and that can have good impact for your papers? So a logical place to start is a discussion of the purpose of what a scientific figure is. So here we have the purpose of the figure is to illustrate, to introduce, and also to emphasize, really to teach the ideas and the data that are otherwise difficult or lengthy to explain through your text, okay? So something like the old adage, a picture is worth more than 1,000 words. Now, there are many types of figures, but two two things that you have to keep in mind are that you must identify the message that you want to tell, okay? And then you must consider who is the audience, who are you going to tell it to, okay? So basically, what is the point of what you are trying to say and who are you saying it to? So for example, in this table, we have some data on gene expression after an infection. So you can see what happens over time for 3 different genes, A, B, and C, over 4 time periods, 1, 2, 4, and 12 hours. But what is the main point here, okay? And what is the best way to present this data? So that if your main point is to show that the gene B has the highest expression after 2 hours, then perhaps you can use a bar graph to show this data, okay? But if you are rather interested in showing the reader what happens to the genes over time, then here it could be best to show a scatter plot like I have shown here, although this is generally best to avoid lines in representing discrete data, because then it can be unclear which points are actually measured. Now, it is easy to think that after publishing an article, your article will be read from front to back in a linear fashion, but this is rarely the case. What is more likely is that the readers will browse your article in a highly non-linear manner, similar to what I have shown here, okay? So they may start with the title, then go on to the abstract, okay? Then it's pretty much likely that from the abstract, the reader will look at your figures, particularly your reviewers and your editors. Okay, so really the figures give the reader the first impression of your work, and in an era of information overload, first impressions are critical, okay? From the figures, then they may go back to the introduction to compare what the intention of the article was, and might pop to the conclusions, okay? And then they might go back and forth between the results and the figures. So identifying both the purpose of your and the audience for the figures will allow you to design the best type of figures and the intended message that you want to send across. Now, we have many types of scientific visualization, and we'll discuss various types of this, of article figures. First is the information density, okay? So you want the figures to be rigorous, but not overwhelming to the readers, such that it confuses or hides the intended message for the figure, okay? So the example here is what we consider a highly information dense figure. The second is the information flow, okay? So you want the readers to be able to comprehend and to follow the information. So the example shown here is considered to be clear because the information flow starts in the centermost circle and flows outward in a clockwise direction, okay? The third is scientific vigor, okay, because of course you want your information to be scientifically valid and it has to be rigorous. So you want your axes to be labeled and the scales to be correct and the lines to be meaningful, okay? So here the dashed line is a partial, as a parity line for this particular experiment, and you want the sizes of the symbols to be useful and not misleading to the reader. The next is figure aesthetics. Okay, so of course, you want the figures to look appealing because appealing figures will draw in the reader. Okay, so On the other hand, if you have unappealing figures, then readers can quickly be turned away from looking at them. And then finally, we have the general point here for description of the figure or the figure caption. Okay, so an adequate description in both the text and the figure caption is critical and is a great opportunity to teach the readers what the figure is discussing. So remember, the most important part of the research article is trying to tell a story of your work as clearly as possible and a way that the reader can easily follow your train of thought, okay, and to be able to arrive at the same conclusions as you have. So when you are thinking about making figures for your research articles, you need to think very deeply about what kind of information, okay, and what is the reader going to take away from that figure, okay? So here we have three categories, broad categories for all scientific articles. The first is illustrative, and this is a general figure that tells the reader what is the plan, okay? This is what the paper is going to talk about. And the second is characterization figures, and this is used to show what we made or what was obtained from the research and what are its properties, okay? And then lastly, we have application figures, and this tends to show off what your system or whatever you were able to produce through your experiment does, okay? What makes it important and what makes it better than existing ones, okay? So each of these figures have some different consideration that you might want to take into consideration when designing them. Okay, a quick look at each of these in detail. Do I still have time?
Yes, Prof, go on. Yes, please. Go
Okay. Okay. I try to finish in 5 minutes or so. So illustrative figures tend to be your graphics or your schematics, okay? So they give the reader a high-level look at your system, and they tend to be some of the first figures that they will come across, okay? So usually these tend to be, for example, figure 1, and they sort of set the tone for the rest of the figure, okay? So some examples, these include schematics where we tell the broad structure of your study, such as in this metabolic engineering paper, which shows progression from cells into gene expression later on, okay? Another example could be synthetic figures, where you show either how you are making a material or a molecule or whatever. And this could be chemical structures or graphics like this one, okay? And this could also be detailed illustrations of your experimental design so that it is very clear for one, for example, what you did, where you took measurements in your experiment, and what treatments were administered during the experiment, okay? So the illustrative figures tend to be the most artistic of all the choices of graphic design and can really set the stage for the rest of the paper. The characterization figures, on the other hand, provide in-depth look into the system that you have created. They provide, they prove that it is what you say it is, okay? So if you are telling of some functional groups that are present in what you have produced to make them function a particular way, then the characterization figures will show how these functional groups appear, okay? And because of this type of figures are usually data heavy, and they include a lot of techniques such as microscopy or spectroscopy or whatever technique you used to characterize your system. Now, as an author, you really need to be critical about what is necessary to see in the main manuscript versus what information is just nice to present, okay? So think about the experiment that you really need to prove your point versus what another research may need to replicate the experiment, so that you may include others that are not so important in the supplemental information, or you can simply describe them in the text. Okay. Then the application figures generally provide proof of concept, okay, to show the potential of your work and to show how exciting or how interesting your work is. Okay, so presentation in terms of quality versus quantity is critical here. All right. Now, in some cases, having benchmark comparisons can be very useful. And often these application figures are the very last thing that the readers will look at in your paper. So you really need to think about what your main takeaway message is going to be. And then you have to emphasize it as clearly as possible. Okay. So it might be like here, as shown in the neurological response, which are highlighted by colors, or it might be photographs of your material performing an action, or graphs that show its performance. Okay. But in any case, your figure should really be here to make it easy for the reader to understand and make clear what the take-home message is going to be. Okay. Now, in the last decades, they have said that the number of items that appears, or the number of panels that appear per figure, has doubled in the past 2 decades. Okay, so that means that you will see many figures that have one figure labeled with different panels. Okay, a lot of panels that are not related. Okay, so you have to be careful making sure that whatever information that you have presented in the panels in your figure are not overwhelming, okay, and they are falling under the same theme. Okay. So I had one more section about writing a compelling introduction, but I suppose time is fast spent now. So maybe it's best for me to stop here. And if there's another chance to continue another day, we will have that opportunity. Okay, so thank you very much, and I will welcome any questions.
Wonderful. Thank you so much, Prof. It's been wonderful, and I just wish you could just keep on going and going. But yeah, I think for the sake of time, we would have to pause here. And well, I hope the organizers will get in touch with Prof to make Prof available as a coach and mentor also, yeah, to a lot of researchers. I think we need some of these things as often and as regular as possible. We might take our notes, but sometimes we need the hands-on advice and coaching, like what Prof has just given us. This is a free opportunity, I would say, for our listeners. Yeah, I see the numbers growing and growing. Yes, breathtaking. Yeah, that's wonderful description of what has just taken place. We have the opportunity within the next 15 minutes. I think for the sake of time, we might want to do it 10. That is why I actually sent notice on the page that you could type your questions so that I quickly read for Prof and I will keep on going. But if you have a pressing question, kindly put it. You can raise your hand too, and I'll call you, or you can type it in, and I will read it for Prof to answer for us. We have the next 15 minutes before we take our 10 minutes break. Okay, Prof, there's a question. Yeah, I think there's a lot of commendation coming. People are saying excellent talk, breathtaking presentation and all. Thank you, Prof, for a wonderful one. But there's a question. Frederick Ni Ofe Bruce says, how do we practice free writing as a researcher? Okay, I think I heard Prof say it in the early stages, but yeah, Prof, if you want to repeat, maybe he didn't.
Okay, so free writing is, as I showed in the slide, you give yourself some timed sessions. So for example, you give yourself every day 1 hour or 2 hours to write, okay? So in this session, you are only going to write what comes to your mind, okay? You are not thinking about how correct they are, okay? So within the time that you have given yourself, write as much as possible what comes into your mind that is going to be used to explain something in your experiment, okay? So for example, you have some results and you need to explain why these results, okay? So you are thinking about it, but you give yourself this timed session to write whatever explanation can come to your mind, okay? There's no need for trying to be correct grammatically or comprehensively, okay? Just put whatever comes to your mind. And then you would have a later time to kind of arrange your thoughts together, okay? So in each section, just put on paper what you think will be helpful to explaining the phenomenon that you have observed, okay? So that will be your free writing.
Thank you very much, Prof. Yeah, Mr. Niofe, I hope your question is answered. Okay, I think everyone was as clear, and we all comprehended as Prof was indeed a very comprehensive lecture, and so maybe people might not have a lot of questions for now, or we are still brainstorming what we've had. I hope okay, yeah, a lot of commendations are coming. Thanks, Prof. Thank you so much, Prof. Yes, I think you were as comprehensive. Okay, I think in the next 2 minutes, if we don't get any more questions, then we can take our quick break. Okay, yeah, very educative. Thank you so much. Yes, great topic. Thanks, Prof. Yeah, a lot of commendations. Yes, thank you. Keep them coming.
Okay, thank you.
Yes, keep them coming. We are going to quickly go for a quick break, and then we will return for our second lecture. In fact, you don't really want to miss this. Introduction to academic surveys. Yes. I see a lot of people sometimes, send some questionnaires in groups, and sometimes you just open it and you just have to just wink at it and just move on. So maybe how do we even go about with some of these surveys and all? We are going to get much more insight into this, and we also have a Q&A with that, and I'm very much happy to let you know that it's my boss himself that will be coming to give that lecture, Dr. Benjamin Ohnik K. Baffo. So you don't want to miss that. But in the meantime, maybe we are just going to take our break for now. Rich says, thank you, Prof. Excellent one. Yes. Okay, someone's hand is up. Osetutu Emmanuel. Oh, sorry. I'm so sorry. All right, Prof. Someone's hand is up. Please, Osetutu, take the stage. Yes.
Yeah, thank you, Bernard, for allowing me to ask my question. I hope you can hear me.
Yes, please. It will even be nice if you could turn on your video. Yeah.
Oh, no, I'm outside, so I think.
Okay, all right.
Okay, Prof, thank you very much for the excellent presentation. Yeah, I just want to have a clear about this. The process of writing, that's building the article. You made a summary about let's say you are building a wall. I want to ask, upon the wall that you have built, first of all, we have methods and results, and on top of it, it captures a conclusion. Then again, you also, on top of the results and discussion, we have introduction. So does it mean that the conclusion have to capture part of the methods and the results? And likewise, the introduction also has to capture results and discussions. And finally, the abstract captures all. Is that how the word or the word explains, or just coincidence?
Okay, thank you very much. So this wall here is only a guide for you as to how to begin writing your articles. Okay, so many people, when they start, they don't know where to start from to start writing the article. Okay, so I have given the process as I think is much easier for people to follow. Okay, and in this process, building on from when you started your experiments, okay, so I said, make your figures as you finish your experiments, okay? So that means that you already have all your figures by the time you finish the experiments, okay? So to start telling your story, then you have to start gathering all these figures that you have made, okay? Now, because you already know what methods you used in the lab, then logically it is easier for you to start writing about the methods, okay? So in the methods, you are only describing what procedures you have used in the lab, okay? And then you follow on to the results. So the result here would be essentially a description of what these figures mean. Okay, you're trying to explain how the figures are behaving, how the data is behaving around the figures. And the discussion here is to try for you to explain, okay, why the figures or whatever data you have is behaving the way that they are behaving, okay? And in behaving so, are they different from what other researchers have said before, or is it entirely a new behavior? Okay, so you have the opportunity to tell us that in the discussion session. Okay, now in the conclusion, we only want to know what is the take-home message after doing all your experiments. What did you find out? Okay, so you're going to tell us the results that you got from your experiment, and what are the implications for the field. Okay, so for example, you were able to produce a catalyst, okay, and then you measured the performance of the catalyst for removing particular pollutants. So the conclusion here will tell us how the catalyst is working and what it can do in the field. Okay, so for example, can it be used for full-scale water treatment, or it's only applicable to lab scale or whatever? Okay, so then the introduction here will try to locate your research within the broader field of that research field. Okay, so for example, you are trying to solve a particular problem that is existing that nobody has been able to solve. Okay, so you tell us that in the introduction. So I wish that I had enough time to go through the introduction. So we have different stages and what you need to tell us about. But essentially, you're trying to, how do you say, fill a research question, okay? And you tell us that in the introduction that this is the problem and this is how I want to fix it, okay? And then you give your objective is essentially the purpose or the activity that you will be doing in the lab to be able to fix or to provide this solution, okay? Then in the abstract, here we are trying to give a general overview of whatever the article is about. So that means that the problem that you are trying to solve should be there. So that is part of the introduction. And the results that you got should also be there. What methods you use to get those results should also be there. And finally, what is the implication of that finding for the field? That should also be part of the abstract, okay? So the abstract, in essence, is just a short form that everybody reading it should be able to know everything almost about your article, okay? And this is the problem I wanted to solve. This is the method I used. This is the result I got, and this is what the results mean. Okay? Does that
Well said,
answer your
and
question?
thank you very much.
Yeah,
Thank
okay.
you.
Yeah,
Thank you very much,
totally.
Prof. And yes, that was nice one. Prof, our break time is up, and we will leave you to rest. It's already,
Okay.
but there's just this last one. I don't know if this person was thinking the way I was thinking. Frederick Neofair is back again with this one. It says, Prof, do we have to only target high quality journals or just do as much as we can? I think, yeah, you would want to share your thought on that.
Okay, so, well, it's not, how do you say, a requirement to target high impact journals. For you as a student, I think now your focus should be how you will be able to graduate, okay? Now, I know many universities have different requirements. Like for my university, you need to have at least one high impact journal article for you to be able to graduate. So if that is a requirement for you, then I think you have no choice, okay? But the other point is that when I was giving the introduction, I said that the articles that you have as a researcher is your career portfolio, okay? So for people to judge the quality of your research, then the impact of your research is very important, okay? So if you really want to make or show that you have that high caliber of research, then you need to have some high impact journal articles, but not necessarily all your articles need to be high impact, okay? You have to have a balance. And I showed you those ranges, depending on what your findings are. Some of the findings you cannot publish in a high impact journal anyway. So there you go, okay? So it all depends on your objective. If you want to be remain in academia where your impact is judged by the publications that you have, then I suppose you have to make that that cut. Okay, so it all depends on you.
All right, it all depends on you. Yeah, if you want people to see your portfolio as rich, you have to, of course, get it higher up there. Yeah, but
one point for some, how do you say, for some universities, if you are a lecturer, to be able to advance to a higher level. So, for example, to advance from maybe a lecturer to a professor level, then you also have that requirement. Okay, so that also depends on whether you want to make that cut or you want to remain as a lecturer for the rest of your life.
For the rest of your life.
Okay. Yeah.
And then that publish or perish come in.
Yeah, publish or perish. Okay. Yeah. So that's the point.
All right. Thank you very much, Prof. It's been wonderful, and it's also nice getting to know you. Yeah, Prof is in Xi'an, and so please, I hope, Prof, Xi'an, someone was asking if we can get your PPT. I think I need it, and a lot of us will need it. I don't know if there's a way we can get it. You could share it with the organizers, and I'm sure they will make it available for us. If it's
okay. Yeah, I think I'm in contact with the organizers, so I can send it to them later.
Thank you very much. Thank you so much.
Okay.
Yes. All right. Thank you so much, everyone. We have 83 members. Wow, that is a wow of attendance. And I hope you all would be very much impacted as I am. We are going to take a quick break. We were supposed to have 10, but I think we've so yeah, we will have to take just 5. Let's take 5 minutes of break. So Mr. DJ, take over, and after 5 minutes, we come here to learn much more about how to conduct our surveys from Mr. Baffo. All right, yeah, DJ, give it to us. 5 minutes. Let's take a break. Thank you so much, Prof.
Okay.
Have a wonderful evening. Yes.
All right. Bye bye, everyone.
Bye, Prof.